Hey everybody, this is Larry. This is day 29 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Yeah, a few more days of the year. Hope everyone had a good year. Market's been tough for me anyway. So, and of course the tech market's also been a little tough. Also for me, I guess. So yeah, I don't know. But let's finish the year strong. Let's finish these few problems and let's go. Today's problem is 1834 single-threaded CPU. I want to also say that today I think there's a weekly one. So yeah. So make sure we'll do the premium one afterwards. So definitely, even if you don't have premium, just come and hang out and I don't know. Let's do it together, I suppose. Okay, so let's do today's. Yeah, 1834 single-threaded CPU. So you're given n task labeled from 0 to n-1 with 2D integer arrays task, okay? Okay, you have a single, so you could only do one at a time. You can choose the one with the shortest processing time. If multiple have them, small index, so you have to basically do it one at a time. So basically, you have to do it one at a time. Getting min. I mean, I think that's that's one thing that I'm not a fan of with respect to the deemed weeks or whatever it is. Because from yesterday, I guess we did heap, and it's hard for me to like pretend I didn't know yesterday we did heap. But this is going to be. But there are things to recognize anyway, which is that the shortest path. Then we do it in this way. I think there are a little bit of return the order in which the CPU processed the tasks. Okay. At time 1, okay. I mean, we just have to sort this, right? So basically, okay. So first we sort the tasks by the enqueue time and the processing time as well. But we actually don't process off this anyway. So. Yeah, and here, maybe we can have a queue because, maybe I'll write it this way instead. Right, so while we have a task, and then maybe we have something like current time is 0, so we start at 0, and then we have a heap that let us do the task, right? So while length of t is greater than 0. I may change my mind on how to implement this later, as this is kind of slightly confusing, maybe perhaps on how they're phrasing. But yeah, but basically, while this is greater than 0, we basically and then we do it. Maybe I could write this in a little different way. I don't know. So maybe while true for now, maybe we'll add a break statement. I mean, we have to, otherwise it'll be an infinite loop. But while this is greater than 0 and the first item, the enqueue time is greater than or equal to the current time, then maybe I'll write it differently though. But basically, we want to push to the heap in this case, right? Because basically now we're saying, okay, let's put it into the things that we can run, So we put it to the heap, and we want it now processed by, what is this? Order in which, okay. So do we have to do the index? Okay, so we have to do a little bit, we want to sort by tasks. This is so weird to do. But we want to enumerate it and then we sort it, but now the key is just the middle element, right? Maybe something like this actually, right? I'm just gonna run it real quick just to make sure my syntax is okay. I think this is okay, but it's easy to kind of have a typo. Okay, so then now we want to push to the heap, and now element 1 is the current. Basically, now we have the index as well because we need it for the answer, and also maybe we have the answer here. just to keep in track. And then now we want to, what do we want to sort by? We want to sort by the processing time. So we want to do something like, this is so yucky, but I wonder if I could do this with the walrus. I don't know that I can do this with the walrus, but let's try it. I'm trying the walrus thing, so let me know. Oh wait, no, because I'm doing like weird comparisons. Yeah, okay, fine. But let's you know, what am I doing here? But yeah, pop left, right? So basically, what do we pop? We pop the index. We pop the time, which we don't need anymore because now we know that it is. Now that it's ready, and then the processing length. So I'm just gonna call it p time, maybe. And then here we want to sort by the PT, and then we'll just keep the index so that we can return it to the answer. And here, instead of having this thing, I mean, we have this as well, but we could set current is equal to maybe something like if length of heap is 0, then we set the current, because otherwise it would just keep on looping. But if we have something on the heap, then we do not necessarily, basically we're just forwarding the current time to the first element. And where is it? 0. Then it's equal to T001. So then this will at least pop one item at least. Okay. Also, we're done when length of T is greater than 0. I guess I could put this here as well. Maybe n or length of heap is greater than 0. Maybe we can change that later. And then okay, so then now after putting all the queue things on the heap, we go, okay, what can we actually run, right? So yeah, so then now we pop off H, yeah, and then we get the PT and index is equal to this, and then answer we put index, and current time we add it to PT. And that's pretty much it, I think. Even though I think I explained this really awkwardly. Oh, this is because the way that we did it, this is actually a tuple that contains those things. Is PT not iterable? Did this pop really? Standard out is 2, so and current is 0. Int not iterable. What does that mean? Is it because I'm shadowing? Let me just put this real quick, just in case. Okay, no, it's still there. So we're popping these two things, and it should be okay. I don't get it. I don't get it. Yeah, you're watching an expert coding silly things. Okay. I mean, this is what we expect, probably. So why? What? Oh, I see. Because this is now wrong. Because this got converted to a tuple. Okay. Wow. And then now we have to compare. This is so awkward. Because the reason why all this is awkward, and we'll fix this anyway, but the reason why this is awkward is because I was lazy here. And basically enumerate returns an index and then the original thing. But the original thing is a list. So then now, this is just terrible code. But well, hopefully by now you know how this works. But okay, so I am putting out the wrong answer for this one. Why is that? Dong dong dong. Oh wait, this is so maybe it did something weird. Yep, okay. I meant to do that, but then I forgot. But basically we want to fast forward, but of course if the beginning of the queue is you know, in the past, then we don't need to fast forward. But this is just for fast forward reasons. And you actually added if statement here, I suppose. Maybe that's what I meant, and that's why I forgot to do it. But yeah, let's give it a submit. Hopefully this is good. Yep. Cool. How did I do it last time? I guess I did it about the same way. Didn't really. Maybe I did it. But yeah, so basically this sorting is going to be n log n. You know, heap, pop is and push is, you know, for each item in the original input, we're only going to push and pop once from the heap. So this entire thing is going to be n log n, and of course O of n for the space, both for the heap and the answer. So you can't really go under that. But yeah, basically the idea is just simulation in a smart way. The way that I would actually think about it, you know, I think I skipped ahead a little bit in some of my explanations, and I apologize for that. Wow, it's been 10 minutes. How did I spend 10 minutes on this? And of course, the first thing you should take a look, to be honest, and I did not do that, so this is my mistake as well, is to look at constraints to make sure that you're doing what is necessary, right? N is 10 to the 5th, so you cannot do n squared. But the way that I would think about it, originally, if you have time to explore this problem, is to write it the n square way. What would the code look like in an n square way? And then you'll find that some part of this will, you know, instead of heap push and heap this pop or sorting, maybe you're doing something where you're just getting min every time, and then getting min of a few things, and that's what the pop does. Instead of doing it in log n time, you do it in O of n time, and that makes it n square, right? So then once you get there, you're like, you know, you ask yourself how you can optimize, and that's basically how I would think about it. Like what parts can you optimize, what data structures can you use? Of course, this will come with experience as well, so, you know, there's no shame in it. That's part of learning. It'll take a while maybe, but yeah. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye-bye.